Fierce, massive, and utterly misunderstood. When you say those words in the context of prehistoric predators, the overwhelming majority of people are going to picture one thing and one thing only: a Tyrannosaurus Rex. And honestly, that makes sense. The T-Rex has been baked into our cultural consciousness for well over a century at this point, dominating everything from museum exhibits to blockbuster movie franchises. It is, for better or worse, the face of predatory dinosaurs. But here is the thing that should genuinely unsettle you, because at some point during the Cretaceous period, roughly 95 to 100 million years ago, there existed a creature so immense, so anatomically extreme, and so ecologically unlike anything we had ever imagined a dinosaur could be, that it fundamentally rewrote the rulebook on prehistoric life. And the most baffling part of the whole story, we almost lost this animal to history not once but twice. That creature is Spinosaurus aegyptiacus. And before you say anything, yes, you have probably heard the name. You might have seen it in Jurassic Park III or caught a documentary mention here and there, but what most people think they know about Spinosaurus is, at best, a fraction of the full picture. And what the full picture reveals is something so strange and so far outside the boundaries of what we assumed large predatory dinosaurs could be, that even seasoned paleontologists have had to fundamentally rethink what the word apex predator actually means. Let's start at the very beginning, because the origin story of Spinosaurus is unlike that of virtually any other dinosaur in the fossil record. In 1910, a German aristocrat and paleontologist by the name of Ernst Freiherr Stromer von Reichenbach set off on an expedition to the Egyptian Sahara, pushing through conditions that most researchers would have turned back from long before reaching the dig site. And across those expeditions, he and his collaborator Richard Markgraf unearthed the partial remains of a dinosaur unlike anything science had encountered. The bones were peculiar in a way that was immediately obvious even with the limited material at hand: enormous conical teeth, a jaw that stretched out like a crocodile's, and most dramatically, vertebral spines shooting nearly 2 meters upward from the backbone, implying a structure on the animal's back that was impossible to ignore. Stromer named the creature Spinosaurus aegyptiacus, the Egyptian spine lizard, and described it formally in a 1915 publication, and that should have been the start of something extraordinary. Instead, what followed was a tragedy that set our understanding of this animal back by decades. As World War II drew to a close and Allied bombing campaigns intensified over Germany, Stromer repeatedly and desperately pleaded with the director of the Bavarian State Collection of Paleontology and Geology in Munich, where his fossils were housed, to relocate the collection to a safer location. The director, an ardent supporter of the Nazi regime and deeply hostile towards Stromer for his public criticisms of the party, refused. On April 24, 1944, a Royal Air Force bombing raid struck Munich, and a direct hit on the museum destroyed Stromer's entire fossil collection, including the only known specimens of Spinosaurus. The bones that Stromer had risked everything to bring out of the Sahara were gone in a single night. All that survived were his notes, his drawings, and a handful of photographs. Stromer himself died in 1952, having watched his life's work turn to ash and having lost 2 of his 3 sons to the war as well. It is one of paleontology's most devastating stories, and for decades afterwards, Spinosaurus lingered in a kind of scientific limbo, a creature we knew existed, sketched from surviving records, but that we could neither fully reconstruct nor deeply understand. That changed, however, in the mid-2000s, and in a way that nobody quite expected. In 2008, a young paleontologist named Nizar Ibrahim was conducting fieldwork in Morocco's Kemkem beds, a stretch of ancient, fossil-rich sandstone along an escarpment near the Moroccan-Algerian border. He came across an unusual collection of bones with a distinctive purple matrix and an unusual bone cross-section. A year later, at a museum in Milan, he was shown what appeared to be a partial Spinosaurus specimen, and he immediately recognized the same distinctive qualities. What followed was a years-long effort to track down the original excavation site, which ultimately led Ibrahim and colleagues to the Kemkem Formation, a region of rock from ancient river deposits dating back roughly 95 to 100 million years, stretching from present-day Morocco toward Egypt. By combining newly recovered material with Stromer's surviving records and photographs, Ibrahim's team described the most complete Spinosaurus skeleton assembled in over a century, publishing their findings in 2014 in the journal Science. And what that skeleton revealed was nothing short of revolutionary. Spinosaurus was big, genuinely, almost incomprehensibly big for a land-dwelling predator. The 2014 study confirmed a length of approximately 15 meters, or just over 49 feet, with some estimates pushing it toward 15 to 18 meters, depending on the modeling used. To put that in perspective, the largest confirmed T-Rex specimen, a massive individual nicknamed Sue, now on display at the Field Museum in Chicago, measures just over 12 meters, or about 40 feet. The largest T-Rex known, a specimen nicknamed Scotty, discovered in Saskatchewan and described formally in 2019, is estimated at around 13 meters and is considered potentially heavier than most Spinosaurus size estimates. But in terms of raw length, Spinosaurus almost certainly had the T-Rex beat. The 2014 study described the newly reconstructed skeleton as more than 9 feet longer than the largest documented T-Rex specimen at that time. This makes Spinosaurus not merely the largest known carnivorous dinosaur, but the largest theropod on record, longer than Giganotosaurus, longer than Carcharodontosaurus, longer than anything else in the fossil record of predatory dinosaurs we have found so far. Let that settle in for a moment. But here is where it gets genuinely strange. Because size is ultimately the least interesting thing about Spinosaurus. What the 2014 skeleton revealed, and what has been further supported by subsequent research, is that Spinosaurus was built in a way that made absolutely no sense for a conventional land predator. Its hind limbs were unusually short relative to its body size, in a proportion more reminiscent of early semi-aquatic mammals than of other large theropods. Its bones were notably dense and compact, a feature seen in modern animals like hippos and penguins, where increased bone density helps with buoyancy control in water. Its feet may have been wide and paddle-like, potentially useful for swimming. Its nostrils were positioned well back from the tip of its elongated snout, which is an adaptation that helps an animal breathe while most of its face is submerged. And its jaw, lined with those long conical teeth perfect for clamping down on slippery prey, was built along the same mechanical principles as a modern crocodile's, optimized for seizing and gripping rather than crushing. Everything about the animal screamed water. Then, in 2020, Ibrahim's team published another landmark paper in the journal Nature, this time describing a nearly complete Spinosaurus tail recovered from the Kem beds, and that tail was extraordinary. Unlike the tails of virtually every other large theropod which tended to be stiffened and counterbalancing, the Spinosaurus tail was structured more like a paddle, tall, flexible neural spines forming a fin-like structure nearly the same length as the rest of the body. Ibrahim described the animal at that point as, and I am being direct here, essentially a river monster. The tail provided propulsion in water in a way nothing else in the dinosaur family tree had ever shown, and it confirmed what the skeletal anatomy had been strongly suggesting for years. Spinosaurus was the first known dinosaur capable of genuinely swimming, an active pursuit predator in an aquatic environment rather than a wader at the shore's edge. Now, to be fair, this interpretation remains actively debated within paleontology. A 2022 study published in eLife by Paul Sereno and colleagues, who were actually co-authors on the 2014 paper, argued that while Spinosaurus clearly had aquatic adaptations, the available evidence better supported a wading lifestyle rather than active deep-water swimming. They compared the animal's biomechanics to those of modern herons and shorebirds, capable in the water, but not a pursuit predator in open river channels. This is genuinely good science happening in real time, and it represents exactly how paleontology is supposed to work, with new evidence constantly reshaping and refining our models. What is not seriously in dispute, however, is that Spinosaurus occupied a fundamentally aquatic or semi-aquatic ecological niche, unlike any other large predatory dinosaur we have discovered. And that distinction matters enormously when you look at where this animal actually lived. The Kem beds in the mid-Cretaceous of North Africa were, based on the fossil assemblage recovered there, one of the most ecologically unusual environments in the history of vertebrate life on this planet. The region was dominated by an enormous river system, vast and branching, lined with wetlands and estuaries, and it was teeming with prey that most terrestrial predators simply could not efficiently access. Giant sawfish called Oncholepristis swam those rivers, some of them measuring several meters long. Enormous coelacanths in the form of Mawsonia lurked in those same waterways. Turtles, large crocodiliforms, and various other aquatic animals filled the ecosystem. This was effectively an all-you-can-eat situation for an animal anatomically wired to hunt in water. According to isotope studies of Spinosaurus tooth enamel published in the literature, the chemical signature in those teeth is consistently closer to that found in contemporary crocodiles and turtles from the same formation than to the teeth of other theropod dinosaurs found in the same area, suggesting that Spinosaurus really did spend the bulk of its life in or around water, consuming aquatic prey. But here is the part of the Kem ecosystem that is so strange it almost defies ecological modeling. Spinosaurus was not the only large predator in that environment, not even close. Sharing that same stretch of Cretaceous North Africa was Carcharodontosaurus, a fully terrestrial theropod that, by the way, was also longer than T. rex, along with Deltadromeus, a long-limbed, lightly built predator that may have specialized in speed, and at least one ablosaurid as well. The density of apex-level carnivores in the Kemkem Formation has no parallel in any modern continental ecosystem we know of. The reason this was even possible, researchers believe, comes down to niche partitioning. Spinosaurus was occupying the aquatic food chain, essentially fishing a resource that none of its terrestrial competitors could efficiently exploit, which allowed multiple giant predators to coexist in the same general region without directly competing for the same prey. Spinosaurus was, in other words, the unchallenged ruler of the rivers, while Carcharodontosaurus dominated the land. Two apex predators, same formation, different worlds. And then there is that sail, or possibly hump, because even that iconic structure on the animal's back, the one that makes Spinosaurus instantly recognizable in silhouette, is still not fully understood after over a century of study. The neural spines projecting from the vertebrae reached heights of nearly 2 meters taller than most adult humans and formed whatever structure covered them in life. 3 primary hypotheses have been proposed over the years. The first is thermoregulation, the idea that a large surface of vascularized skin could have helped the animal manage heat in a tropical environment. The second is a bison-like fat or muscle hump, with some researchers arguing that the proportions of those spines are more similar to the high-withered ungulates of modern Africa than to any known sail-backed animal. The third is display, meaning the structure served primarily as a visual signal for species recognition, mate attraction, or rival intimidation. A hypothesis that gained further traction when a 2024 preprint review found display to be the most consistently supported function given the sail's large surface area. A fourth and more recent idea is that the submerged structure might have provided some hydrodynamic benefit in water, functioning as a kind of stabilizer during swimming, though this remains speculative. As of right now, no single hypothesis has been conclusively ruled in or out. The sail is genuinely one of paleontology's most debated open questions, and the honest answer is that we do not know. What we do know is that taken together, the length exceeding any other carnivorous dinosaur on record, the paddle-shaped tail, the dense bones, the croc-like jaw wired for fish hunting, the extraordinary fossil history, Spinosaurus represents something paleontology almost lost entirely. A 100-million-year-old river monster that Darwin himself would have struggled to predict, built by evolution along a completely different blueprint than everything else in the theropod family tree. It was not competing with T-Rex. It was not even playing the same game. While T-Rex was the consummate land predator built for endurance, bone-crushing force, and the pursuit of massive terrestrial prey, Spinosaurus had already colonized an entirely different world, one that was wet, vast, and filled with prey that nothing else in its environment could touch. The story of Spinosaurus is not just a story about a big animal. It is a story about how radically evolution can reshape a body plan when the pressures are right. About how a single bombing raid in 1944 nearly erased one of the most important animals in the history of life on Earth. And about how science, messy, contested, and ongoing, can pull something extraordinary back from the edge of obscurity. And somehow, after everything this animal has been through, we are still only beginning to understand what it truly was.